Question 1. Select the correct answer from the menu. The size of the population, P, can be calculated with the following equation. So they're giving us the equation, giving us the formula for this problem. In the equation, P sub 0 represents the initial population size. R represents the population's growth rate, and T represents the time in years. A population of frogs in a pond currently has 50 individuals and grows at a rate of 30% per year. It will take the population approximately how many years to double in size? So really nothing new with this problem that we've already discussed. The 30% is the easiest to identify. That is, of course, is our R for this problem. The 50 individuals, so this is our initial population of frogs. So we're starting with 50, so that's P sub 0. They're obviously looking for the number of years, so we're trying to solve for T in this problem, which means, okay, we have something for P sub 0, we have something for R. To be able to solve for T, we have to know what this is equal to. So the P value comes right here at the very end of the problem. They want to know how many years we are doubling in size. So if we started with 50 initially, that means P is going to be double that. So P is 100. So I'm going to take this formula. I'm going to replace P with 100. I'm going to substitute P sub 0 with 50. 1 plus the rate, which is 0.30. Don't forget to take 30%, divide it by 100, and that's equivalent to 0.30. We're raising that to the T power. So first off, to solve for T, of course we could work this backwards. It's good to know the forwards way to solve it. Let's divide both sides by 50. Let's divide that parentheses coefficient by itself from both sides, and we end up with 2 equals 1 plus 0.3 is just 1.3 raised to the T power. All right, I'm going to move it up here in the top right corner. So I've got a little more space. So now at this point, to solve for T, we got to do the opposite, the inverse operation of raising something to the T power. So we've just discussed logarithms, and we've talked about one of the log properties where we can move that exponent out of the exponent spot and into the coefficient spot. So recall this property. The log of base of something x raised to the n power is the same thing as n times the log base b x. So that n can move to the front of the logarithm. Of course, we have to have a logarithm in this problem to begin with. So what we're going to do, we're going to take the log of both sides. And since we're taking the log of both sides, we're assuming this is log base 10. So now we can use that third property. This t can move to the front in the coefficient spot of this logarithm, so it becomes t times log base 10. I'm not going to write the 10 this time, it's just assumed to be there, equals log 2. And we could type in log 2 in the calculator and get that answer, but let's just wait. To solve for t, we're going to divide both sides by the log of 1.3. Those will cancel. And then the log of 2 divided by the log of 1.3 should give us a reasonable answer for t in this problem. So the log button, this is different in every calculator. The log of 2. I'm going to hit enter, so it gives me that full decimal, but I don't want to round that decimal. And I'm just going to divide that answer by the log of 1.3. Close the parenthesis. 2.64, and I look at the answer key. The answer key is exactly 2.64.